Hello, good morning students. Today we will see the next part of the chapter, that is environmental issues. So in the last class we had stopped, or we were talking about the water pollution and its control. So in the last class we have seen that which are the causes of, or which are the causes for that is pollution of water. Okay, so in the present slide also you can see that the domestic sewage and the industrial effluents, okay, are responsible for causing, that is, water pollution. That is here you can see that water hyacinth, the picture of the water hyacinth is given on given in the slide. Okay, above, that is the purple flowers, you can see water hyacinth, or it is also called as Icornia carispes, is a problematic weed which is also called as terror of Bengal. Okay, this weed you can see usually growing in the polluted water. They grow very abundantly in eutrophic water bodies or the polluted water bodies, and if, that is, suppose if this cornea is growing in any water body, that means that water is highly polluted. Okay, then you can also see that your sewage which is coming from the homes, okay, and the sewage which is coming from hospitals, and they are going to contain many undesirable pathogenic microorganisms that are responsible for causing, or they are responsible for the outbreak of serious disease such as dysentery, then typhoid, jaundice, cholera, etc. And then your industries also, your just like your domestic waste, the domestic sewage, the wastewater is also going to come from the industry also, and that the whatever which is coming from the industries, industries like your petroleum and paper manufacturing industries, it will contain it will contain many harmful substances, you can say. That is, industry may be anything, that is, industries may be like petroleum, paper manufacturing, metal extraction and processing, chemical manufacturing, etc. Whatever the water is coming out from these industries, it is very toxic because it will contain number of heavy metals, you can say, like mercury, cadmium, copper, lead, etc., and many of the harmful organic compounds. Okay, so here, and these all the substances, they are going to make your water polluted, okay, which is unfit for drinking. Then this few toxic substances are there which are present in your industrial waste waters. Those will lead to a phenomena which is called as biomagnification. Okay, so here, that is biomagnification. Here you can say that is a biomagnification, or you can also call it as a biological magnification. So then what do you mean by this biological magnification? As I already told you, industrial water waste contains, that is, certain waste materials which undergo biological magnification. Okay, so biological magnification is nothing but it is the accumulation of toxicants like mercury, DDT, etc. at successive tropic levels of the food chain. Why this occurs then? You may ask me the question. Why does these toxicants undergo accumulation? Because these wastes, they cannot be degraded, or they cannot be completely metabolized. So in that case, what happens is the organisms cannot metabolize or excrete the toxicants. So as they are unable to throw out these chemicals or these toxic materials out of the body, that time these chemicals, they go on passing on to the next generation. Okay, so that time what happens is, you can say, when they are not able to get excreted, they will be sent to next trophic level of the food chain. So especially this, you can see in the diagram, the biomagnification is shown in the aquatic food chain. So here in this case, you can say biomagnification refers to increase in the concentration of the toxicants at the successive tropic levels. Okay, so as you go on to the next higher and higher toxic levels, higher and higher tropic levels, the concentration of the toxicants also increases. And this is all because a toxic substance which is accumulated by the organism, which is present inside the organism, cannot be excreted or it cannot be broken down. Hence, it is passed to next higher tropic level. Okay, and this phenomena you can better study with the help of the phenomena of biomagnification is well seen, taking the example of mercury and DDT. So here, that is ppm refer first here, that is you can see the diagram they have given, that is water which will contain your producers, which may the plants which are eaten by the zooplanktons. Okay, then these zooplanktons will be eaten by the small fishes, which will be again eaten by the large fishes, then again in turn will be eaten by fish eating birds. So here you can see in the next slide, so in detail, that is biomagnification of DDT in aquatic food chain. By taking the example of the biomagnification of DDT in the aquatic food chain, they have very well explained regarding biomagnification. So in this manner, that is you can see here in the water, that is many producers will be there which will be containing 0. That is 0.00003 parts per billion of DDT. Okay, that is water will contain, in the diagram also you can see they have mentioned the numbers, or else you can see on the right side of the slide, that is water which will contain the DDT concentration of DDT. Everyone knows this DDT. Okay, it is very much famous, that is DDT which is used for your killing of your ants. Okay, so that DDT in water it may be 0.003 ppb. Then this DDT, when it is eaten, it is taken by, which is consumed by the that is or suppose you take the DDT is there in the water, which will be eaten by or engulfed by zooplanktons. So that time the this DDT will be taken inside the body of this zooplankton, and that the concentration of the DDT will increase to 0.04 ppm, that is parts per million. Then again next you can see this zooplanktons will be again in turn eaten by fishes, that is 0.5 ppm. Then again it will be eaten by the large fishes, where you can see there is gradually increase in the concentration of your DDT, that is in large fishes you can see 2 ppm, that is parts per million of your DDT. And then in your, then these large fishes will be eaten by the birds, where the again you can see there is increase in the concentration of your DDT. So here what happens is, as you move on, that is move on in the as the successive tropic levels. Okay, that is it is starting with 0.000 ppb, it is parts per billion in water, and then it ultimately finally it is going to reach 25 ppm, that is parts per million in fish eating birds. Okay, through biomagnification. So you may ask me question, what is the harm, what happens if there is increase in the concentration of this DDT at each tropic level? You can see that this DDT, when it reaches the in case of birds at the higher tropic level, this DDT is going to disturb the calcium metabolism in birds. Okay, so this DDT is going to cause harm in the calcium metabolism in the birds, which in turn lead to thinning of the eggshells. You know very well that is birds will lay the eggs will have the shell. Okay, so when there is this DDT concentration is more in case of birds, that will lead to the what happens, that is whatever the eggs are laid by these birds, those eggshell birds they are going to lay the eggs, but the shell of these eggs are very thin. It is because of the problem which is caused by a DDT. And then if there is shell is very thin, that will lead to their premature breaking. There is chance, if the shell is not strong enough, if it is very thin, that may lead to the breaking of the shell of the egg, and thereby it will lead to the declination, or it will decrease the bird population. If suppose if a bird is laying 10 eggs, and if the shell is very thin, that is and due to accidental damage, that is they may break because of the very thin shell, and then instead of 10 birds coming out from the 10 eggs, if some of the eggs get destroyed, so suppose 5 eggs get destroyed, only 5 birds are going to get hatched or come out. That will lead to the decrease in the bird population. That will lead into decrease of the bird population. Then next is this you have seen. Then next one is regarding you can say the about next thing. This is all about the biomagnification or biological magnification. Then there's this biological magnification. They may ask you for 2 marks or 3 marks question. That is, write a note on biological magnification. That time you should write about this biomagnification. We're taking the example of the DDT, that is biomagnification of DDT in aquatic food chain. Then in the next part we will move on to the next part, that is eutrophication. Okay, so then what do you mean by this eutrophication? Eutrophication is nothing but the definition of eutrophication. It's also very important. So eutrophication is nothing but the natural aging of the lake. Then you may ask me how the lake is going to get aged. Lake is nothing but it is a kind of water body. Then your eutrophication is nothing but it is the natural aging of the lake by nutrient enrichment. When the nutrient goes on increasing, the nutrient quality of the water, when it goes on increasing, that is going to lead to aging of the lake, and that phenomenon is nothing but the eutrophication. You can see that a young lake is there, a fresh lake where the water will be very cold and clear. Okay, and it will be supporting your little life. Okay, so here when the time comes that slowly what happens, when as the time goes on, the streams are going to drain into the, that is when as the time goes on, the different types of streams are going to drain into the lake. Okay, number of, that is water is flowing from different houses or any other parts, and along with the water it is going to carry many of the nutrients such as nitrogen and phosphorus, and that nitrogen and phosphorus which is coming along the stream into the lake will lead to the increase in the soil fertility. Okay, the stream is the stream of water which is running towards the lake is going to introduce number of nutrients like nitrogen and phosphorus, and introduction of such nutrients into the lake is going to encourage the growth of aquatic organisms. Okay, and as the lake's fertility increases, not only a plant population increases, along with that you can say that there is a your animal life is also going to increase. And then slowly what happens is your organic remains begin to get deposited on the bottom of the lake. Then over the centuries, as the time goes on increasing, as the time is going on spending over the centuries, or 10 years, 20 years, 30 years, 50 years, like that, your silt and organic debris, they are going to pile up. Okay, means they are going to increase and increase. Earlier the lake was very deep. Okay, water was very clear, but as your nutrient goes on increasing, organic matter goes on increasing, what happens is here silt and the organic debris which are present in the water are going to come up and up and up, and what happens is your lake will become shallow, and it will become water in the lake will become warm. Okay, and then what happens is again the habitat of that water is also going to change. That is, earlier the lake was very that is deep, clear, and it had cold water, but as the organic matter of the water changed, Okay, organic matter of the water increase, that will lead to the lake to become very warm, and that will encourage the growth of organisms which are loving to live in warm water. Okay, so now there is also replacement of organism also. Earlier there were organisms which lived in cold water, but now slowly as the that is the water became warmer, the warm water loving organisms uh, replace the cold loving organisms. Then slowly what happens here, marsh plants take root in the shallow water, and they fill the original lake basin or the, you can, floor, you can see, and eventually slowly you can see that is the lake gives away to large mass of floating plants and finally converting them into land. So here in the picture they have given you, in the diagram they have shown you how the lake was before and after. Okay, earlier the water was deep and it was clear enough and cold one. After the deposition of your nutrients and the piling of the water, piling up of the organic debris, that will support the growth of your floating plants, and the that is it was converted into land. Okay, so this is about eutrophication. Here also in the next slide you can see here eutrophication, that is depending upon the climate, size of the lake and other factors, the natural aging of the lake may span. Okay, so here may span thousands of years. However, pollutants like effluents from the industries, homes accelerate eutrophication. So in eutrophication also you are going to have that is natural eutrophication as well as accelerated eutrophication. Natural eutrophication means that is no interference of man, that is naturally only in nature that is going to occur, that is eutrophication. That is nothing but the aging of the lake, aging of the lake which is going to occur naturally, that is natural eutrophication, which depends upon the climate, size of the lake and other factors. But sometimes what happens due to human pollution which is caused by human or due to human activities, that is when the effluents get mixed up with these lakes, that will increase, it will speed up the rate of eutrophication, that is called as cultural or accelerated eutrophication. This may also be asked for 2 marks question or 3 marks question. Write a note on eutrophication or define eutrophication, they also may ask you the question. Then here the prime that is you can say that you may ask me then what will be the reason for eutrophication. Here that is usually when you see the history of the past centuries, you can see that the lakes uh, in many parts of the earth have become severely eutrophied by sewage and agriculture and industrial waste. But mainly the prime contaminants which are present in this water are nothing but your nitrates and phosphates. What do they do then? These nitrates and phosphates, they are mainly responsible for eutrophication because these two substances, they are going to act like plant nutrients. What do they do exactly? That is, these phosphates and nitrates, they are going to overstimulate the growth of algae, causing, what happens is when there is growth of algae, it causes unsightly scum and unpleasant odors. You can see here in the diagram below on the left side, the below diagram, that is a man who is holding in his hand green color liquid. You can see it is nothing but the overgrowth of the algae, and when there is overgrowth of algae, it causes unsightly scum and unpleasant odors. Water starts smelling, and it is all because the dissolved oxygen of that water is going to decrease, and when the dissolved oxygen of the water is going to decrease, that will lead to the, it is death of many of the other aquatic life. Okay, so the main reason is for the eutrophication is nothing but the presence of nitrates and phosphates in that water. Okay, so here this due to eutrophication, you can say that at the same time, that is other pollutants which are flowing into the lake may also poison the whole population of fishes whose decomposition remains that is decomposition is not going to take place. That is, suppose a lake is there, and not only due to the eutrophication can occur, or due to your nitrates and phosphate. Along with that, there may be other some reasons, that is the poison which is coming out from the many of the industries may also cause the fishes to die in that water. And when there is, that is when the fishes die, they are not going to undergo decomposition because there is less oxygen content. In that fashion, in that case, the lake may completely choke up to death. Okay, because in that lake there is no oxygen. All the aquatic animals have died because the water has become poisonous and it has already undergone eutrophication. Then next one is about the eutrophication, that is uh, heated thermal waters which are flowing out of the electricity generating units. For example, thermal power plants. They are also going to act like a main reason for the eutrophication. Okay, so here again you can say it may enhance the growth of plants and fishes in extremely cold areas, but only after causing damage to the indigenous flora and fauna. You can see some pictures of eutrophication which has occurred. They have shown it. So here, that is thermal pollution, you can call this as. Okay, thermal pollution, or you can that is aging of the lake also you can consider it. That is the in thermal pollution, that is the heated waters which are coming up to the electricity generating units. Okay, when you add it to the normal lakes, they are going to act like pollutants. Okay, and when the hot water, whatever, suppose the lake has cold water earlier there were the fishes or the animals which used to live in cold water, but suddenly if you add hot water to that, that is going to have a bad impact on the indigenous flora and fauna. So that time, slowly as you go on in adding this hot water, that is going to help to the growth of plants and fishes which uh, grow in that environment rather than the indigenous. Okay, so this thermal water elements eliminates is going to reduce the number of organisms which are sensitive to high temperature, and it will enhance the growth of plants and fishes which are living in extremely cold areas. Okay, so this is how, that is eutrophication and a brief account on thermal pollution. The next one is water pollution and its control. In that, you will study a case study of integrated wastewater treatment. So here in this, what did they do is what they want to tell is wastewater, including your sewage water, can be treated in an integrated manner. Okay, so integrated manner, you can treat this wastewater by using both artificial as well as natural process. One such example they have shown, that is one such example they have quoted here. Okay, that is they say that it was an initiative was taken in a town of Arcata, which was situated along the northern coast of California. Okay, so one initiative, one attempt was done, one trial was done in the town of Arcata, and this town is situated along north coast of California. What did they do is, these people, they collaborated with the biologist from Humboldt State University, and then the that is these people, they what did they do is, townspeople and biologists both together in collaboration from the Humboldt State University, they created an integrated wastewater treatment process. Okay, so they did an attempt to treat the sewage water. Okay, so what exactly did they do? That is, here these people, that is, they collaborate, as I already told you, along with people, along with the Humboldt State University. What did they do is they did a cleaning, that is cleaning project of Arcata, in which the cleaning process is going to include, or the cleaning process occurs in two stages. The first one is a conventional sedimentation, filtering and chlorine treatments. Then the that was the first thing what they did. And the next thing is the biologists developed a 6 series of connected marshes. Like this, in 2 steps the cleaning work was done. First one is about the sedimentation, then filtering and chlorine treatment. So here what it did is, that is a dirty water, they did the sedimentation. The sedimentation means they allowed it to for settling. Then when it settled down, that is heavy particles are going to settle at the bottom. Then next that water was taken for filtering. Then that water was treated with chlorine. So after this, whatever the remaining pollutants like dissolved heavy metals were there, were removed using an innovative approach. So then, by sedimentation, filtering and chlorine treatment, all the heavy metals or heavy materials were all, or dissolved materials, heavy metals were all removed. Then next what did they do is, next thing is, these biologists developed a series of 6 connected marshes. Marshes means these are the wetlands which are connected, which are connected, which are dominated by herbaceous plants. Wetlands, lands which are dominated by herbaceous plants. So such that is 6 connected marshes were there, which were spread across 60 hectares of marshland. Then in that marshland, what was there? So this marshland, 60 acres of marshland contained appropriate plants, algae, fungi and bacteria, then which were present in this area. Okay, then this whatever the water which was treated with sedimentation, filtration and chlorine was allowed to flow in this that is 6 connected marshland, which was spread to 60 acres of land. In 60 hectares of land, these 6 connected marsh areas were marshlands were there. Okay, then the water was spread over there, and this water which was spread, what happened, as marshlands contained algae, fungi and bacteria. Okay, what did they do is this, these algae, fungi and bacteria, they neutralized, absorbed and assimilated the pollutants, and thereby the water which was flowing out of these marshlands got purified naturally. Okay, so what happened, that is 60 hectares of land was there, which was divided into 6 marshlands. And this marshland, as I already told you, marshland is nothing but it is a wet land which is dominated by herbaceous plants. So there were 6 such patches. That 6 patches had number of plants which were growing, then algae, fungi were growing, and bacteria were also allowed to grow. When you allow this polluted water to go through these marshlands, and after coming out, at finally the water will come out of this. Okay, that time what happened is, these algae, bacteria, fungi, these absorbed, neutralized different pollutants, and then thereby the water which flowed out through the marshes got purified naturally. Okay, so this marshes that is also constitute a sanctuary with a high level of biodiversity in the form of fishes, animals and birds. This marshlands, which was spread in 60 hectares of land, will constitute a sanctuary. Why sanctuary? Because it had higher biodiversity level of fishes, animals and birds. So here what happened is, here also a citizen group called as FOAM, that is Friends of Arcata Marsh, is a citizens group for the upkeep and safeguarding of this project. Who took care of these marshlands? That is the Foam people. Foam is nothing but the Friends of Arcata Marsh. They took care of these they took care that they looked after these project. Okay. And then coming to next one is about the ecological sanitation. Okay, so here always we thought that removal of waste requires water, that is creation of sewage. For example, if you go to potty, okay, a toilet, or for cleaning the toilet you require water, and when you clean the water with the toilet, when you clean the toilet with the water, that water will become sewage. But what if water is not necessary to dispose of human waste? Can you think about this? No using water for cleaning the human waste or sewage. Okay, can you imagine? Not in India, because we all use water. Okay, right, for cleaning the human excreta of the toilet, and thereby we are creating the lots of sewage water. Why can't we think of that is reducing the, or why can't we think of that is disposing of human waste without water? Okay, so that method also can be done. That is nothing but your ecological sanitation. Okay, so when you are not using the water for cleaning your toilet, or when you go for toilet don't use water, that is how you can reduce the use of water. You can save so much of water. Okay, so you already know, you go for a toilet, you flush the toilet with the water, and thereby you are going to create the sewage water. Okay, imagine if you are not flushing your toilet with the water, and thereby you are adopting another method, that is nothing but the ecological sanitation. So what exactly do you mean by ecological sanitation then? So ecological sanitation is nothing but it is a sustainable system for handling human excreta using dry composting toilets. These dry composting toilets or ecological sanitation are present in many of the countries or many of the areas also in India. Many of the states are going to adopt this. So here you can say in ecological sanitation, what is there is, you are going to do sustainable system, a systematic plan for handling human excreta using dry composting toilet. Okay, so this method is very practical, hygienic as well as efficient, and moreover it is less cost efficient. Okay, the key point is here is that uh, here that with this method, that is by this ecological sanitation, human excreta we can be recycled into a resource, that is as a natural fertilizer, which is going to reduce the need of chemical fertilizer. That's the idea behind this. That is, human excreta can be recycled into a resource. And therefore, eco-scan toilets, you can see they are present in many areas of Kerala and Sri Lanka, where they don't go for using of water to clean the human excreta. Instead of that, they are going to handle the human excreta by doing it by using dry composting toilets. And this human excreta is excreted can be used as a natural fertilizer, which is the best way to reduce a chemical fertilizer. Okay, then next thing is about the that is water pollution ban. That is, Government of India has passed the Water Prevention and Control Pollution Act in 1974 to safeguard water resources. Okay, the next is about the next part of this chapter is regarding the solid waste, which we will see in the next upcoming slide. Okay.